Hello, this is TSS Vani, Department of ECE, BVC Engineering College, Vadalrevu. In previous slide, we have discussed about the architecture of 8086. Now, I am going to present the signal description of 8086 microprocessor. Coming to the signal description, it is a 40-pin IC package. 8086, it is a 40-pin IC package, dual inline package. The clock rates of this microprocessor is 5, 8 to 10 megahertz. Here some of the pins serve a particular function in minimum mode. Minimum mode means it is a single processor, and other functions operates in maximum mode. Maximum mode means it is a multi-processor configuration. It is a total 40-pin IC package. In this RQ bar by GT0 bar, some pins are applicable only in maximum mode and some pins are applicable only for minimum mode. The maximum mode pins are RQ bar by GT0 bar, RQ bar by GT1 bar, log bar, S2 bar, S1 bar, S0 bar, QS0, QS1. Okay, these pins are applicable only in maximum mode, and minimum mode pins are hold, HLDA, WR bar, M by IO bar, DT by R bar, DEN bar, ALE, INTA bar. These pins are applicable only in minimum mode, and remaining pins are applicable for both minimum mode as well as maximum mode. Coming to the signal description, here the following pins the following signal descriptions is common for both the minimum mode and maximum mode. In this, the first pins are AD0 to AD15. AD0 to AD15, okay, these are time multiplexed memory, IO address and data lines. Address remains on the lines during T1 state, while the data is available on the data bus during T2, T3, TW and T4. Here T1, T2, T3, T4 and TW are the clock states of machine cycle. TW is the wait state. And coming to the next pins, A19 by S6, A18 by S5, A17 by S4, A16 by S3. These are the time multiplexed address and status lines. During T1, these are the most significant address lines for memory operation. During IO operation, these lines are low. During memory or IO operation, status information is available on those lines for T2, T3, TW and T4. The status of the interrupt enable flag bit is updated at the beginning of each clock cycle. Here S4 and S3 together indicates which segment register is being presently used for memory access. Okay, if it is 00, the data can access from alternate data. Alternate data means it is an extra segment. If it is 01, the data can access from stack segment. If it is 10, code segment. If it is 11, data segment. This is about S4 and S3. And S5, it represents status of the interrupt enable flag bits. And S6 is always low. So the address bits are separated from status bits using latches controlled by ALE signal. And coming to the BHE bar by S7, the bus high enable is used to indicate the transfer of data over the higher order, that is D15 to D8 data bus. It goes low for the data transfer over D15 to D8 and is used to derive chips select of add address memory bank peripherals. BHE bar is low during T1 for read, write and interrupt acknowledge cycles whenever a byte is to be transferred on the higher byte of the data bus. Here the BHE bar and A0 both together we can call it as bank enabled signals. These two indicates the data transfer. So suppose if it is 00, BHE bar 0 and A0 is 0, whole word will be transferred. If it is 01, upper byte will be transferred. If it is 10, lower byte. If it is 11, none of the data will be transferred. So this represents this BHE bar and A0 both together we can call it as bank enabled signals. And coming to the RD, it is a RD bar, it is a active low signal. Read signal when low indicates the peripheral that processor is performing a memory or IO read operation. RD bar is active low and shows the state for T2, T3, TW of any read cycle. Coming to the read, this is the acknowledgement from the slow devices or memory that they have completed the data transfer. Simply the read signal, it represents the acknowledgement from the slow devices only. Next, INTR, interrupt request. This is a level triggered input. This is sampled during the last clock cycle of each instruction to determine the availability of the request. If any interrupt request is pending, the processor enters the interrupt acknowledge cycles. Next, coming to test bar, this is a input examined by wait instruction. If the test input bar goes low, execution will continue, else the processor remains in idle state. Coming to the NMI, non-maskable interrupt. This is an edge triggered input which causes type 2 interrupt. The NMI is not maskable internally by any software. Coming to the reset, this input causes the processor to terminate the current activity and start execution from FFF0H. Clock input. The clock input provides the basic timing for processor operation and bus control activity. It's an asymmetric square wave with 33% duty cycle. VCC, all of you know, that is a power supply, plus 5 volts power supply for the operation of the internal circuit. Similarly, ground is there and ground for internal circuits. Next pin, MN by MX bar. MN by MX bar. MX bar, it is a active low signal. MN, it is a active high signal. The logic level at this pin decides whether the processor is to operate either minimum mode or maximum mode. Okay. Whenever this pin MN by MX bar, whenever this pin goes high, the processor operates in minimum mode. Whenever this pin goes low, the processor can operate in maximum mode. Okay, up to these pins is common for both, applicable for both minimum as well as maximum modes. And next, coming to the minimum mode pins. The first pin is M by IO bar. This is a status line logically equivalent to S2 bar in the maximum mode. When it is low, it indicates the CPU is having IO operation. When it is high, it indicates that CPU is having memory operation. Next, interrupt acknowledge. It is a active low signal INTA whole bar. It is a interrupt acknowledge INTA whole bar. This signal is used as a read strobe for interrupt acknowledge cycles. In other words, when it goes low, it means that the processor has accepted the interrupt. Next, coming to the ALE, address latch enable. This output signal indicates the availability of the valid address on the address data lines. Coming to the data transmit receive, or simply we can call it as DT by R bar. DT by R bar. Receive, it is a active low, data transmit is active high. This output is used to decide the direction of data flow through the transceivers. Transceivers means it is a bidirectional buffers. When the processor sends out data, this signal is high, and when the processor is receiving the data, this signal is low. Next, coming to the data enable, it is also active low, or simply we can call it as DEN whole bar. This signal indicates the availability of the valid data over the address data lines. It is used to enable the transceivers. Transceivers means it is a bidirectional buffers to separate the data from the multiplexed address data signal. Next, Up to this it is a minimum mode pins, and now we have discussed about maximum mode pins. The first one is and one more pin is there, that is in minimum mode, that is hold and hold acknowledgement. When the hold line goes high, it indicates to the processor that another master is requesting for the bus access. The processor, after receiving the hold request, issues the hold acknowledgement signal on HLDA pin in the middle of the next clock cycle after completing the current bus. Okay, up to these pins it is only applicable for minimum mode. Now from this pin onwards it is applicable only for maximum mode. Okay, the first pins are S2, S1 bar and S0 bar. These are called status lines. It indicates S2 bar, S1 bar, S0 bar, it is a status lines. These are the status lines which indicates the type of operation. These status lines indicates the type of operation being carried out by the processor. Suppose all are zeros, 0, 0, 0, the processor operation is interrupt acknowledge. If it is 0, 0, 1, 0, 0, 1, the processor can read IO port. If it is 0, 1, 0, the processor can write IO port. If it is 0, 1, 1, halt. If it is 1, 0, 0, code access. If it is 1, 0, 1, read memory. If it is 1, 1, 0, write memory. If all are 1, it represents passive. Simply these three status lines which indicates the type of operation being carried out by the processor. Next, lock, it is a active low. This output pin indicates that other system bus master will be prevented from gaining the system bus. While the lock bar signal is low, the lock bar signal is activated by the lock prefix instruction and remains active until the completion of the next instruction. Coming to the QS1, QS0, that is Q status. These lines gives information about the status of the code prefetch Q. It represents a table QS1 and QS0. Simply it represents the status of Q. If it is 0, 0, no operation. If it is 0, 1, first bit of opcode from the Q. Empty Q represents 1, 0. If 1, 0 is there, that represents empty Q. If the subsequent bytes from the Q, okay, it shows 1, 1. And last pin, that is request grant, or simply RQ bar by GT0 bar and RQ bar by GT1 bar. So these pins are used by the other local bus master in maximum mode to force the processor to release the local bus at the end of the processor. Each of the pin is bidirectional with RQ bar by GT0 bar having higher priority than RQ bar by GT1 bar. Okay, this is the complete description of pin diagram. Thank you.